everyone. Welcome to the Bureau of Reclamation SEAL Team Fix Challenge webinar. Thank you for taking the time to join us today. Please feel free to say hello in the chat and let us know where you're joining us from. Our agenda for today will be to provide an introduction of our panelists, then an overview of the challenge along with how to enter and submit your solution, and then we'll move into the Q&A. So just a reminder, please submit your questions for the Q&A to the Q&A box on your screen. We may not get to all the questions on today's webinar. For those that we don't cover, we'll look to respond to them via the challenge page, and we'll also upload a recording of today's webinar to the challenge page. So starting us off with introductions, I'm Andrew Osansky, a project manager with HeroX, and we're partnered with the Bureau of Reclamation to administer this challenge. I'm now going to pass it over to Bobby Jo Merton to begin with the introductions for the panelists team.
Hello, everyone. My name is Bobby Jo Merton. I work with the Bureau of Reclamation at our Technical Service Center in Denver, Colorado. I am part of our prize competition team, and I help oversee prize competitions in the infrastructure sustainability area. And I'm going to next pass over to Christine Van Zomeren, and then we'll introduce the rest of our reclamation team.
Thanks, Bobby Jo. My name is Christine Van Zomeren. I'm the prize competition program administrator. So I work in a broad portfolio that includes this prize competition. My portfolio meets Reclamation's missions within the 3 theme areas. And one of those Bobby Jo mentioned on infrastructure sustainability. Well, I'm in Denver, and I am supported by a team of subject matter experts that are also on this call. So thanks for joining, and I'll move it over to Ian.
Hi there. I'm a mechanical engineer at the Bureau of Reclamation Technical Service Center. I specialize in large gates and valves, and I'll be helping with this competition. I'll pass it over to Keisha.
Hi, my name is Keisha Florisma. I'm a mechanical engineer at the Denver Technical Service Center of Bureau of Reclamation, and I specialize in fish equipment such as trash racks. And I'll be helping out with this prize competition as well.
I'll go ahead and go. I'm Jeff Garner. I'm in Boise in the Pacific Northwest region, and my specialty is in power O&M, so power plant operations and maintenance.
Great. Thank you, everyone, for the introductions. I'm now going to pass it over to Ian Blythe to provide an overview of the challenge.
All right, pulling up the presentation now. Let's see here. All right, well, first of all, thank you all for your interest in this challenge. All of us here at the Bureau of Reclamation are excited to see the solutions that might come out of this. Just to get started, I wanted to talk about this picture because I think it demonstrates some of the key features in this competition. So this is Shasta Dam, and you can notice they're making releases from this from the 18 outlet conduits. So just for scale, each of these conduits are about 10 feet in diameter, and they're controlled by large valves within the dam that are embedded in concrete. On the face of the dam, not visible, there's a large bird cage trash rack structure that prevents debris that may be submerged from getting into the conduits. And this is typical of reclamation facilities, but as we'll get into later, there's not a lot of consistency or standardization. So next, also visible are the 5 power pen stocks. These are even larger, and you can see they're emerging from the face of the dam and running to the power plant that is just off, out of frame here. And these have gates on the upstream side as well as a trash rack, and on the downstream side, there's a turbine shutoff valve just upstream of the power plant. So any of the failure of any of these features would cause an uncontrolled release of water to the river downstream. So a little more about the Bureau of Reclamation. So our mission is to manage, develop, and protect water and related resources in an environmentally and economically sound manner in the interest of the American public. So we operate and maintain water and power projects in the 17 Western states. We're the nation's largest wholesale water supplier and the second largest hydropower producer. We maintain a complex network of civil structures, pipelines, canals, dams, more. So we have over 490 dams and over 8,000 miles of water distribution systems. We provide irrigation water for 10 million acres of farmland that produce much of the nation's vegetables, fruits, and nuts. And we have 53 hydroelectric power plants that together produce 40 billion kilowatt hours annually. That's about enough power to supply 4 million US homes. So why is this an important challenge to solve for us? So failures at dams are extremely uncommon. These dams were built with numerous safeguards. They're generally well maintained and routinely inspected. However, many of these were built about 100 years ago, and a lot has changed in the past century. Although the valves and penstocks were designed conservatively using the best information available, our understanding of seismology, flood forecasting, and steel design and fatigue have come a long ways. And simultaneously, the consequences of failures has increased as downstream populations have grown. Therefore, by sponsoring this challenge, Reclamation hopes to add a tool to our emergency response toolbox. If an uncontrolled release of water were to occur, the existing safeguards were to fail, then your solution to this challenge would have important safety, ecologic, and economic consequences. Uncontrolled releases, as long as they're happening, they are causing severe damage to the dam. Also, they're causing flooding downstream, which could threaten lives, communities, infrastructure, exacerbate erosion, and damage downstream ecosystems. Finally, the water in the reservoirs has economic value for irrigation and power generation and recreation. So this is an important challenge for us for all of those reasons. Why hasn't this challenge been solved already? So the first thing is access and safety. The inlets might be submerged between 20 to 350 feet below the water surface. Downstream access may be submerged or it may be really space constrained. Trash racks add complexity to getting access to these inlets. And the dam itself, like the crest of the dam, it's a narrow road with space and weight restrictions. So typical construction equipment may be too large or too heavy. The solution is difficult to scale because the intakes are not standardized. These are all individual design projects that solved a lot of problems in different ways. So we have conduits from 3 to 25 feet in diameter and many different trash rack designs. The intakes could be square and transition to round conduits, or they might be round and transition to a square valve or gate. So additionally, trash racks, it could be a bird cage that goes from the intake all the way to the surface of the water, or it might be a box structure that covers just a single intake. And there's others as well. So it's going to be a challenge. So we are asking you to develop a solution to a loss of control of a large conduit. Whether the loss of control is due to a rupture of the conduit, inoperability or failure of a control mechanism, or something else. So this picture shows kind of a generic intake structure. You have an emergency gate and a penstock and an intake. So for your solution to have value to us, it needs to be rapidly deployable. The faster the better, ideally 1 to 2 days. As I mentioned, an uncontrolled release is causing damage to the dam itself. Reclamation would be extremely uncomfortable with divers anywhere near an uncontrolled release. The pressures, velocities, volume of water we are talking about, along with extremely low visibility, makes any solution involving divers a non-starter. The visibility is like hand in front of your face down close to a structure like this. So the solution needs to be safe and reliable. A good solution will allow workers to safely begin repair downstream. And the solution needs to be capable of sealing a wide range of flow and pressure conditions. It needs to be adaptable to varied intake geometry, and it needs to be designed to remain functional for extended periods of time, up to a year. The solution needs to account for pressure differential. So the upstream side, if your solution is somewhere in here, the upstream side is subjected to reservoir pressure, and the downstream side might be atmospheric. Additionally, these conduits, they're designed for incremental closure. The gate doesn't close instantaneously, it closes slowly, and this vent is sized for that closure and for the size of the downstream conduit. If your solution had created a perfect seal right here and it's sealed instantaneously, it would almost certainly collapse the penstock downstream, which would be an even bigger problem. The incremental sealing is a critical part of this challenge. The solution needs to be designed to be eventually removed after repairs are made. And finally, keep in mind the structural loads your solution is imparting on the dam are designed for reservoir on the dam and conduit. Some features, like the walls of the penstock and the face of the dam, they're designed to take reservoir pressures. Other features, like trash rack support structures, they're designed just for a few feet of differential head pressure. So as you're developing your design, keep in mind where your reactions are. So the structure of the challenge, phase 1 is concept design. Phase 2 is prototype development. Phase 3, demonstration and testing. We're currently in phase 1. You're delivering a white paper, and in phase 2, you're going to develop the actual prototype. Phase 3, we're testing your prototype in our hydraulics lab. All right, so phase 1, concept design phase, we're looking for schematics, illustrations, anything explaining how your solution works, and a description of how the solution is deployed, what materials and processes are going to be used. We also want to see the estimated seal effectiveness and durability, and if you foresee a gradual loss or increase in effectiveness over time. Please support your claims with calculations that support your design principles. These submissions are going to be reviewed by a team of reclamation engineers and scientists, so be as technical as you want. The submission should explain how the 4 engineering functions are addressed. Deployment at the dam. You can also explain how your solution would be transported to the reservoir if that's applicable. How your solution incrementally obstructs the flow and eventually seals, as well as the expected seal performance. And finally, how the system is eventually going to be removed. You can also explain if the system is reusable. The photos here, so on top is an example of an intake structure. These guides, they hold trash racks, and the top is likely where an emergency gate is lowered into place. On the bottom, this is a regulating gate discharging at the base of the dam. So these are 2 different dams, but you can imagine that between the regulating gate and the emergency gate is a pressurized conduit. So phase 1 submissions, they're due October 14th. They must include a realistic project plan as well as a timeline for phase 2 and phase 3. Up to 5 of the best solutions will advance to phase 2. Winners will each receive $50,000 that is intended to support prototyping efforts. Phase 2 prototype development. We're converting phase 1 concepts into functional prototypes, estimated 6 to 9 months. Demonstrate function and constructability. Solution addresses critical requirements, can be reasonably validated through controlled testing in phase 3. There's a check-in with experts, and the winners, there'll be up to 3 who will receive $75,000 and advance to phase 3. The midpoint check-ins are intended for discussion of progress with subject matter experts, including those on the panel today, where you can get clarification to understand if you guys are on the right track. Phase 3 is demonstration and testing, where we test your phase 2 solution in the reclamation laboratory. Selected phase 2 solutions will be tested to verify functional deployment and retrieval, incremental conduit sealing, stability under different pressure scenarios and pressure spikes, and effectiveness of the seal. The target remains 95 to 98% sealing. Phase 3, phase 2 winners will deliver the prototype to reclamation laboratory, where we will evaluate it. This photo is from the reclamation hydraulics lab, and the testing setup could look similar to this. You can see the arrow is pointing at some different sized intakes, and this is a regular ladder for scale of the size of the testing. Why would you participate beyond the monetary prize? So hopefully there will be some prestige and visibility to this solution, media exposure and credibility with government agencies. This is an important mission, solving a real world problem with potentially high impact. And hopefully if the solution is good and it's widely adopted, this could open doors for future government contracts. This is the timeline. October 14th is the submission deadline. 16th, we'll announce phase 1 winners, and everything else we are still developing. All right, thank you all.
Great, thank you, Ian. Appreciate that. I'm going to go ahead and screen share our challenge page and just show everyone where you can get more information on the challenge and go ahead and then submit your solution. So this is the challenge page on HeroX. It's herox.com/SEALTeamFix. That's where you'll find all the information about the challenge. The summary tab is going to give you the overview and the guidelines. In particular, the timeline. I know we've mentioned it a few times, but just another reminder, October 14th is our submission deadline. Updates is where you can find out about any updates that we're sharing related to the challenge. This is also where we'll share the recording of the webinar. And the forum is where you can go ahead and ask any questions that you may have while you're working on your submission. When you are ready to go ahead and create your submission, you can just go ahead and click solve this challenge, accept the legal agreement, and you'll be able to load your submission up to through the challenge page. All right, we are now going to move into the Q&A portion of today's webinar. Again, just a reminder, please add your questions to the Q&A box you'll see along the bottom of your screen there. So I'm going to begin with the questions. All right, first question here. If the trash rack is part of a concrete structure on the face of the dam, can the solution seat against, i.e. bear load, on this concrete structure? Yeah,
I think I'm taking that one. So as I mentioned, trash racks, they're only designed for a few feet of head differential. And you can assume that the concrete structure that is supporting those trash racks is designed for similar loads. So I would say no, depending on how much head is expected at the intake. I wouldn't consider trash rack supports capable of bearing structural loads of your sealing solution.
Excellent. Thank you, Ian. Will the hydraulic laboratory testing have trash racks to navigate with the prototype solution? And what is the estimated head pressure and flow rate during testing?
That's a question I can help answer. We're really excited about the laboratory testing. It is an impressive laboratory that we have here. We're not quite sure of the details, so those will still be worked out. But it is envisioned that a trash rack is not likely to be scaled for use during that evaluation. And same with the pressure and flow conditions. We expect to scale them to be similar to what's outlined in the prize challenge guidelines.
Well, thank you. Next question. Can you talk more about why solutions involving divers are not within scope for this challenge?
So it really just comes down to safety. And during an uncontrolled release, we are really uncomfortable with the idea of a person getting injured or killed in while solving this challenge or installing a solution. We have a dive team here at Reclamation, and it's really challenging to do any work submerged on these facilities. There's no visibility. There is no way to safely tie off, and that's part of the design, like the constraints of this challenge is not relying on divers.
Thank you, Ian. Are there any dams of concern that may be modeled to try to find an exact solution?
I can take that if you'd like me to. We're still working out the phase 2 and phase 3 details, and we look forward to working with those selected participants at that time. And that could include some discussion around potentially giving, maybe not specifically a dam of interest, but the features, the design parameters, so to speak, that would lead you to help solve that solution using those specific parameters. That's of course recognizing that we do want a flexible, adaptable solution. That is a requirement of this challenge, but if needed to help support and guide developing a solution, I think that's something we'd entertain.
Thank you. Could the system be deployable through gate bulkhead slots or only externally?
Well, one issue is that not all intakes have gate bulkhead slots. So it's a fair solution for those that do, but what we are really looking for is a general solution. And relying on features that are not always there is not really a general solution. Hope that answers the question.
Thank you, Ian. Next question, how do we access the conduit with the trash rack in the way?
I can answer that question. So one way that you can access the conduit is by making the trash rack removable. So that will require the trash rack to be hinged. So you can open the trash rack like a gate to have access in the conduit. Another way is by using hoist or cranes that are available on site.
Great, thank you. Will the evaluation consider solutions that can adapt to both circular conduits and intake towers with rectangular openings?
Ideally, the solution would be able to handle any sort of geometry that you could see in a dam.
Thank you, Ian. All right, what is the average diameter of the spillway outlet, and is it always rounded? And what is the depth range?
So it's not always rounded. The depth range I think we've been quoting is 20 to 350 feet. Sorry, I forgot the rest of the question. Could you repeat it?
No problem. I'll just repeat the full question. What is the average diameter of the spillway outlet, and is it always rounded? And what is the depth range?
Average, maybe 10 feet, 8 feet. But like we said in the presentation, 3 to 25 feet is commonly seen.
Excellent, thank you. Next question, you mentioned the visibility is very low down there. Do you think using lights will help or will not do anything at all?
So our dive team does use lights, but it's really when they're doing a trash rack inspection, the way it's been described to me is that it's much more of like you're just feeling with your hands along the trash rack for corrosion or things that are broken. And they have good lights. And also when they're doing it, there's not an uncontrolled release happening. So there's no, disturbance of the water. So I would expect a lot more debris to be flowing through the water during an uncontrolled release, sediment to be in the water, and there to be, visibility would be even worse under releasing conditions.
Thank you. Is there ever a situation where there are 2 or more conduits vertically on top of each other? Also, please clarify the minimum or maximum spacing in the trash racks where materials can flow through. So I think that's 2 questions there. So I don't know if one person wants to take them or we could split them up.
I can talk about the geometry of the gates or the intakes. It is. I can't think of any facilities that have 2 gates merging back into the same conduit. That being said, I can't say that has never happened. Sometimes what you'll see is an intake tower that has multiple gates releasing water into the intake tower. So in that case, yes, but and then all the water would be merging into one larger conduit. So I guess I answered the question there of yes, and I'll kick to Keisha to answer the question about the trash rack bar spacing.
As far as the bar spacing goes, it can range anywhere from, I would say, 3/8 clear spacing, 3/8 of an inch clear spacing to 6 inches. So it depends on the debris that will be at the inlet of the conduit. So the smaller the debris is, the smaller the spacing is required to be, and the larger the debris is, the larger spacing that the trash rack is required to be.
Thank you. All right. Will you accept a solution to phase 1 only? I think meaning that just a concept and a solution that's not potentially able to move forward.
I think we would say yes, we would accept a solution to phase 1 only. However, if you look carefully at the judging criteria, you need to have a really well-developed plan for phase 2 and phase 3. So if you plan to submit for phase 1 and you also do accompany that material, it could still be possible for you to win a phase 1 prize. Ultimately, though, we are hoping that we get 5 phase 1 winners that are selected and advance them through phase 2 and phase 3.
Thank you. Will teams receive any support from Reclamation in phase 2 and phase 3? And can we reach out if we have questions during these phases?
I can take that one too. Yes, we do encourage you to reach out to us when you have questions. Those will go directly to HeroX, who will help facilitate us getting responses to you. We also intend to have midpoint check-in meetings. And as Ian said during the presentation, we really see that as a beneficial opportunity for both parties. We can get to understand what you're working on a little bit better and really help ensure that we're steering you in the best direction possible, or to really help you in your chances of being successful in this competition. And as Ian said, those are our subject matter experts at Reclamation. We anticipate the team of panelists that you see here today to be those who'll be primarily interfacing with you during that period.
Excellent, thank you. Next question, can you provide more information about bulkhead guides?
So I guess I want to ask specifically, what do you want to know about the guides for whoever asked the question?
If you could please drop that into the Q&A and we can come back to that question. I think that'll be helpful. All right, let's come back to that. We'll ask another question in between, and hopefully we'll get a few more details there to help us out. What do you see as missing in the solutions already on the market, and has Reclamation tried existing solutions? What were the outcomes?
The dams are generally built with a regulating gate and an emergency gate, and that has been a satisfactory solution generally forever. There's not a lot of documented issues with that. Sometimes a gate stops working, but usually it is we're capable of getting it sealed and closed. So what has been tried is not really like there hasn't been an emergency where we're making uncontrolled releases for months at a time or days at a time. I guess I could think there was one really famous radial gate failure at Folsom that released water for like months before it got down, but that's not really the type of that's the only like mechanical issue that I can think of. But the idea of this challenge is to find a solution or have something in our toolkit for if a disaster happens someday in the future. So that's why we're having this competition. I hope that answers the question. But yeah, typically the emergency regulating gate system has worked. Bulkhead and stop log guides are also helpful when they're there. Trash racks typically work. So this is to add a tool to our emergency response toolkit.
Excellent, thank you. And it looks like we did get some more information on the bulkhead guides question. So the additional detail is there a metal plate inside or not?
So are you referring to inside the concrete? If you are, the guides are steel and they are embedded in the concrete. I'm not sure if that answers the question.
Let's hope so, but if not, please feel free to add any follow-up questions into the chat. We can add to it. We could come back to that one again if we need to there. All right, so next question. Can you explain the 1 to 2 day deployment limitations? When does the time start, i.e. once the equipment arrives at the site or once the notice is sent that a failure has happened?
I can address that one. So for the purpose of the competition, we're asking, just to have some kind of metric that this can be something deployable in 1 to 2 days. So working through thinking about why we selected that number, and we are thinking about from the time of notice, or the time that we become aware of a failure, because of how critical time is. So we understand that deploying something in a matter of hours is probably unreasonable, and we may need to ship something to a site to help address this. But ideally, if we were to have an uncontrolled release, we want to be able to stop that flow as quickly as possible. So here we're giving a target of approximately 1 to 2 days. The shorter, the better, though, in this case.
Excellent, thank you. All right, next question. Why is Reclamation using a challenge approach for this project?
I can take this one. We use prize competitions for a number of reasons. A lot of the reason is an innovation. We are reaching out beyond our traditional expertise to go outside of what we would consider maybe traditional expertise. And that provides an opportunity to bring new ideas and innovate alongside our subject matter expertise. So this also provides an opportunity to stimulate private sector prototyping and work in this space. It does provide opportunities to provide funding for innovative ideas in a more non-traditional way, where you're receiving payment for solutions that on the back end that we've received that we're interested in. So there's a lot of benefits to using this innovative approach to crowdsourcing and bringing new, fresh ideas to our agency.
Excellent, thank you. Next question, how does Reclamation intend to use the winning solutions from this challenge?
I can answer that one. We envision that this competition will move into prototyping in phase 2, and in phase 3 evaluation, we'll get even more information about the suitability of that prototype. So we recognize that it's earlier in the technology readiness level scale, and that there would need to be some additional development. But moving forward, if we were able to successfully work through those development stages, we would be happy to have this solution to use for our inventory. In the cases that we've been describing today, emergency type cases, but we also know that through innovation, you can find other uses that can make some of the work that we do for maintenance now or other purposes, potentially much more efficient or safer.
Well, thank you. Next question, is Reclamation exploring any other approaches beyond crowdsourcing to solve this problem?
I mean, I think the approach we're taking is continuing to maintain our facilities and replacing old, like, aging equipment. That's the main, and that takes most of our time, I think. So that's the idea of getting another solution that is out there for us to use. Maybe Jeff could say something about that, though, if you want.
Yeah, I would say that as far as being able to, one instance comes to mind as far as just, having valves, and one specific instance where we have some of these valves are submerged, and then some of the structures has been damaged and it's really old, and just being able to have that availability, even for this, in some instances, even in a non-emergency, having something like this would really benefit us being able to maintain something like a downstream outlet valve that is very difficult to maintain because we might not have a way to close it off on the upstream side of the dam. I don't know if that helps.
Well, yeah, thank you. All right, well, we have, it looks like I was just going to say we don't have any further questions, but it looked like another one just popped up in the Q&A there. So we'll just give it a moment there. And we are getting close to time here, so if you do have any remaining questions, please add them to the Q&A box there at the bottom of your screen. All right, just waiting to see if it comes up for me here. Well, here's another question we can ask, actually. Could you talk in a little more detail about your vision for the prototype phase and proof of concept demonstration?
I can take that one if you'd like. So prototyping is always a really good opportunity. And as you've seen, we've outlined a lot of criteria. We have a pretty complex challenge here. So we're looking forward to seeing how those physical engineering type elements of a prototype kind of come together, given all those constraints, like the high head, the flow, needing to be able to do it rapidly, having some potentially like logistics challenges for getting it on site. And then finally, just being able to have a good seal, to make a good seal while incrementally closing over that conduit opening. So while a theoretical competition could have given us some really good ideas, we saw this one as potentially having a lot more value if we can move into those physical prototypes and be able to test what's going well and where the shortcomings or limitations are.
Excellent, thank you. And thank you all for your time today. Please do keep in mind that the submission deadline is coming up on October 14th. For any questions that we may not have covered, please look for responses on the challenge page. And we're also going to upload a recording of today's webinar onto the challenge page. So thank you all for your time. Thank you to our panelists for taking the time today. And we look forward to seeing all of your submissions. Have a great afternoon.